We have a string then this will be a spring. This will be the natural length of the spring that will have natural length. Let me, for our convenient, we'll write it. So this is x naught. So now kx naught equal to mg. Maximum value of x for which the motion of particle will remain simple on weak motion. I think x should be less than x naught. If it becomes more than x naught, if the spring is compressed, it should be x naught only. I will redraw it. I'll make it a little bit small. Let me have it. So kx naught, this mg. If I pull the I'm going to stretch it by distance x. So how much of spring force will act? Kx naught plus x. If this x is less than x naught, okay, fine. It's going to execute SHM. If x is less than x naught, we'll see. In this case, the block will go here. What is the state of the spring? Spring will be still remain stretched only. And it's going to execute SHM. If it becomes more than x naught, then so what will happen to the string?
Become slack.
It will become slack. If x is greater than x naught, it will cross this line. Maximum permitted value is, the spring should be relaxed here. So x is equal to x naught. Maximum permitted value of x will be x naught. I think the objectives can be asked, very simple idea. The maximum tension in the string if x equal to mg by 2k, where the maximum tension is possible at the main position at the lower extreme only. Let me come to the next part. Worst case, go for diagram, otherwise not needed. With the maximum tension string if x equal to, so here spring force will be kx naught plus x. Then what is the state of here? The spring force will act here also, no? And this is what the string. So this will be slack taut taut. Okay, agree this. This will be. So now we'll calculate that one. M equal to kx naught plus x minus mg. Kx naught equal to mg, we know, and kx is equal to mg by 2. Maximum tension is asking, so that maximum tension will be, now this tension will be maximum. Kx naught is mg, kx is mg by 2. Where the tension, when the tension the string will maximum, at all the time it will be T max, or when the block is at lower extreme it will be T max. When the block is at lower extreme, it will be T max. Okay, string, only cord, elastic cord I discussed in the class. Please do verify that. They're very important. I do have diagrams. I think I'll check the paper. I solved it. Yeah, we have that. Why to read off so many? Just see the diagrams. I thought diagrams will at least will help you to understand the question. This came in weekend exam, if you can remember. So initially, when the spring is this first diagram you look at here. Initially, when the blocks are at rest, kx naught, the tension will become internal. So therefore, the kx naught should be equal to 3 mg. Leave it. And how much of tension the string? The brown color is the string. Please do notice. T naught equal to 2 mg. So what is the initial elongation of the spring? Kx naught. This is the natural length of spring. This is the initial elongation. Write it. Yeah. What is L naught? Natural length of the spring. Spring can undergo compression or relaxed. What will be that? Okay, now let's get into the concept here. I'm going to say, let's not bother the question. First, we'll learn this question, what actually happens. Then we'll go and verify the option. This one, don't directly attack the options. And like, okay, let me pull this, the block 2m by x. So I have this string. So how much 2m moves, that much m will move. So this is what x here. Even this also has moved by x. Then I'll release it. Definitely what happened earlier, spring force was balancing the weight. Now spring force is greater than weight, so the system will accelerate. So kx naught plus x minus mg, and the string will be taut. That condition we have to write it. Okay, string will be taut. So let's write the equation. Kx naught plus minus mg minus t is equal to ma. This is for upper block. For lower block, t minus 2mg equal to 2ma. Since we know from equilibrium, kx naught equal to 3mg, what is that? This is an equilibrium. Either imagine or draw diagram. Two options are there for you. This is very important. Okay, this will be. So kx naught. So solving this, so eliminating this, we'll get acceleration equal to g. Then let me calculate the tension. Substituting this a equal to g, I'll get the tension 4 mg. What I substituted, when kx equal to 3 mg, then I'm getting this tension equal to this much. Are you noticing this? You see this, sir? Why you are writing kx equal to 3 mg? The other condition is given when kx equal to when x equal to 3 mg by k. When you pull this block by distance x, then is asking the condition where this tension will be maximum. That 4 mg. When this is at lower extreme only, the tension the string will be maximum when the block 2m is at lower extreme. This is a lower extreme. Again, when it comes to mean position, they allow common speed, Vm and Vm. Okay, leave it here. Now, because of velocity, it will start ascending up. It will start ascending up. So somewhere, let me take this particular position. Let me take this position here. So if this x is equal to kx, x not equal to 3 mg by k, and in fact x equal to 3 mg by k. So shall I say it will come to this position. So what is the state of the blocks? Instantaneous rest. And what will be the tension here? Will be 2 mg, no? The tension the string will be equal to 2 mg. After this, again, it will move down. So like that, what when it will be executing SHM. So what is the time period of all these blocks? For all non-zero values of x, no, only for permitted. If x greater than 3 mg by k, what will happen? Let's come to the question. If x is greater than if x is greater than 3 mg by k, then what will to this block? It will cross over this one. Then string will be compressed, spring force will act, and it will be loose. String will be loose, I'm writing. And what is the state of spring? Will be compressed. You see, everything is there in the diagram. So therefore, what is the permitted value of x? Should be less than 3 mg by k. If it is greater than 3 mg by k, it will become loose. And what is the tension? Tension will be zero, no? When x equal to 3 mg by k, minimum tension is 2 mg. When x greater than 3 mg by k, minimum tension what will be zero. String will be loose. This option will not pick up. Motion will remain simple harmonic motion for this one. So so what is it? Why I picked up earlier like a string, spring, now yes, spring and string, then elastic cord. I have discussion. So just revise all this possibility of asking any question in advance.
Why minimum tension 2 mg, sir?
Here only possible, no?
Why can't it be 0?
Zero when it can happen here. Here 2 mg is acting here, no, all the time. Here mg is acting. What is the state of spring? Spring will be here just straight. It will be straight here. So here the tension will be there. Zero can happen here. When it becomes slack, it will become zero. Check the diagrams once.